but you need to know, be able to separate in your mind and know all those wonderful things. So if I look at that water bottle, what do I have in here? What are all these little things in here? What are all these little things? What do you think these are? These little dots here. What do you think those are? What? No, they're not atoms. They are molecules of what? Okay, molecules H2O. Very good. So those are water molecules. And you have billions upon trillions upon quadrillions, gigaplex, a ton of them in there. And you are using that a lot, quite often. All right, so let's see. Can we do this? What do you think? Okay, matter is anything that takes up, is a material that makes up all things, anything that occupies, has mass and occupies space. All right, so in here, name something you can't see that has matter.
Air.
Air absolutely has matter. The space that air is taking up is the shape of the room. That's this space that it's occupying. All right, name something you see that has, that you can see that has matter. You. Me. Okay, good. Absolutely. All right, so those are some easy things that you know. Anything has matter. Anything. All right, anything. All right, a pure substance is classified as a type of matter with a fixed or definite composition. So if something doesn't change, all right, if something doesn't change, like water is always H2O, carbon dioxide always CO2, silver, gold, lead, frankincense, and myrrh. Get ready for Christmas. I know it's not Halloween yet, but just get ready for Christmas. My kid wants a big monster truck. So you better write Santa on, you better draw it, because I don't know what it is. But anyways, all right. So an element that is composed of one type of atom. So elements are made up of atoms. So anything on that periodic table, which we're going to have our spelling bee in about 2 weeks, of all of them, if you don't get one wrong and you stay in until the end, you're the winner. You get bonus points on your chapter 3-4 test. For your spelling bee, I have my little bell I ring. So if you want to start memorizing some of them, you can do that now. Y'all just line up just like a spelling bee. Come up and I say N, and you say nitrogen. 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 And you walk to the back of the line because you didn't get a bell. If you get it wrong, Gracie, I ring the bell. And you have to go. You're out. All right. So it's a fun game. It's fun. And then we have a compound that is composed of 2 or more elements combined in the same proportion. All right. Simple things like, all right, NaCl, all right, CaF2, calcium fluoride. We could have some water up here. We could have some carbon dioxide. We could have silver. All right. We could also have, nitrogen. All right, by itself, elemental, because we know that we have 7 diatomics. I bring clay for our new house, which we'll talk about here in a little bit. Okay, I'm rambling on stuff I don't need to. Elements, pure substances that contain only one type of material, such as copper, lead, aluminum. All right, those are some simple ones. All the symbols are up there. Lead is actually a Latin term, plumbic, or plumbus. All right, plumbus would be the lower Pb with a 2+ charge. Plumbic would be the higher Pb 4+ charge. All right, so there are definitely some Latin names in here. Okay? Okay. All right, a compound consists of 2 or more elements in a definite ratio: salt, table sugar, water. I don't really like classifying water as a compound. I like classifying it as a molecule. For me, a compound consists of metal, nonmetals. So compound and molecule, they're interchanging here, because sugar, that's a molecule, water is a molecule. But for now, for your liking, we'll just say that that they can be compounds. So they have a definite ratio. You can't change it and make it H3O without giving it a charge and making it hydronium, which we'll do later. Okay, salt, table salt, is a compound that contains elements of sodium and chlorine. So I have sodium metal, chlorine gas. Take a look here real quick. Each one of these balls is just an Na. All right, so this is just Na, Na. These guys, how do they exist? What do they look like? What do they look like? Do they have two balls or one ball? Two balls. All right, so it exists as Cl2. That is chlorine. All right, so chlorine is what we call a diatomic. Unless it is elemental, just Cl. In nature, it's always going to exist as Cl2. Just as something else. What else exists as something 2? O2, N2, all right? I2, F2, Br2, hydrogen, H2. All right, so chlorine is 1. You should start getting that in your memory banks now. All right. A mixture is a type of matter that consists of 2 or more substances that are physically mixed, not chemically combined. 2 or more substances in a different proportions, substances that can be separated by physical methods. Do you have any type of mixture that you can separate very easily in your mixture that you just made by just physically separating them? Yes? Somebody tell me what you can do, how you can do that. Did anybody use zinc? Raise your hand if you use zinc. Well, what was your plan to separate zinc? Yeah?
I was just gonna drain it, not drain it, but make all the sugar go through and then.
Okay, yeah. Yeah, just take tweezers and pick the pieces out. That's a physical mixture, all right? So that's the same as a salad. Could be a mixture. Well, I don't like tomatoes or onions on my salad, so what do I do to get them out? I take them out, all right? I'm not a raw tomato guy, all right? I don't like raw tomatoes. So you can physically separate these things. All right, next. In a homogeneous mixture, homo means what? It means the same. All right, same. Homogeneous mixture, the composition is uniform throughout the sample. The different parts of the mixture are not visible, such as brass. Brass is a homogeneous mixture. How about this one? What about this? Is this a homogeneous mixture? Composition uniform throughout? Or are you getting pelted with some large ozone molecules and you're walking down the hall and you do this, do that? Is that what you're doing? No, that doesn't happen? All right, so that's uniform throughout. You don't see any different colors in the air unless you're maybe existing in Los Angeles or China has some bad air right now. All right, you can probably see some physically different parts called smog. All right, the different parts of the mixtures are not visible. How about milk? Well, milk has some different parts. Obviously, it has a lot of sugar in it. All right, so it definitely has a lot of different parts. All right, so those are some homogeneous. Same throughout. It looks the same throughout. Heterogeneous is different. The composition varies from one part of the mixture to another. The different parts of a mixture are visible. All right, so that's pretty easy. What if I had lemonade, freshly squeezed? Freshly squeezed. What do you think? Do you see different parts of that? If I freshly squeeze a lemonade or orange juice, what do you see in that? What do you see? Pulp. Pulp. All right, so you see pulp in there. All right, that would make it heterogeneous. If I added ice cubes to it, if I added ice cubes to milk, it would now be heterogeneous. Something that you can physically see the different parts of. A salad. What you have right now. All of you have a heterogeneous mixture. Something you can include in your conclusion. you all have a heterogeneous mixture because you had to use either brown sugar or zinc, or iodine. It's all going to look different. They all look different. So if you physically see the difference, it's going to be heterogeneous. Hetero means difference. Okay. Classification of matter. I would memorize this chart. There's no question that I would memorize this chart for multiple choice type questions. I think you have the chart, right? In your textbook, yes. All right? So you want to make sure that you memorize it. It will also be on the YouTube video that I'm recording right now. Okay? So it'll be on there as well. If you want to take a look at it. Everything that we just went over is here. A couple things you want to know. Elements cannot be separated into simpler substances by chemical means. You can't break them down anymore. Splitting an element would cause what to happen? A nuclear explosion, right? That's called nuclear fission. When you split an atom, you think that's a lot of energy or a little bit of energy released? Lots. All right? Compounds can be separated into simpler substances by chemical means. Pure mixture. All right, let's go. All right, next. Identify each of the following as a pure substance or a mixture. All right? What do you got? What's about the first one? All right, pasta and tomato. All right, mixture. Aluminum foil. Pure. Why? It's just aluminum. It's just aluminum. Aluminum is an element. Helium. Pure. Air. Mixture. All right. Very good. Here are the answers. All right, you guys got them all right. Pat yourself on the back. That's good. I always like to physically pat myself on the back. Going to the foot doctor here in a little bit, but now my foot's feeling fine, so it's great. It's awesome, right? When you don't have to go, when you can only get in when everything's good, right? All right, identify the following as homogeneous or heterogeneous. What do we got? A hot fudge sundae. Hetero. Hetero. All right, normal shampoo. Homo. Sugar water. Sugar water. Homo. You're not going to see the sugar unless you put too much sugar in it. Peach pie. Hetero. All right? So remember, you can put a ton of sugar in water, i.e. a soda, and if you pour out a Coca-Cola, does it all look the same except for the bubbles? Yeah, it all looks the same. So you can put a ton of sugar. Now remember, to make Coca-Cola, they heat it up really hot so they can add more sugar and can dissolve in it. Then they pressurize it and put it in a can and give it to you. Or me. You know? And that's what they do. So you can definitely get those wonderful things. There are the answers if you're checking them out at home on your lovely YouTube video. Sorry for all of those on retreat today. 3.2, states and properties of matter. All right, matter has characteristics called physical and chemical properties. Can somebody give me an idea of a physical property? Yes? What? Shape. Okay, shape. Yeah. What else? Yeah. Temperature. Okay, normal temperature. Physical property. What? Color is a physical property. All right, yes. Feel is a physical property. All right, yes. All right, the weight of it. Okay, very good. All right, we're kind of getting off track of those things. So let's talk about a couple of those. Physical properties are characteristics observed or measured without changing the identity of a substance. Shape, which we got. Physical state, solid, liquid, gas, or plasma. All right, solid, liquid, gas, or plasma. I had a freshman come up to me this year, and he goes, hey, there's another state of matter. There's plasma. And I go, yeah, I've known that for about 20 years. Okay, but he was all excited to tell me. That's what I like. They gotta have that energy. Gas. I don't know why I say gas of plasma. Gas or plasma. Come on, Bowers, get it together. Why do you make me write that? Or plasma. Okay, boiling and freezing points. All right. Density is a physical property. Density measured in grams per milliliter. All right. And color. Okay, so we got a lot of them. That was good. We got a lot of them. Now we have to do chemical properties. Ooh, chemical properties. I like density, boiling and freezing points. Remember, we are always using boiling and freezing points in degrees Celsius. Okay? Here we go. Physical and chemical properties of copper. Copper is reddish-orange color, shiny, excellent conductor of heat and electricity, solid at 25 degrees, melting point 1,083, boiling point 2567. Now, does anybody ever drive on 216 Skaggsville Road out to 95? Okay, no? Okay, well, there's a large field of copper wound spools. Copper in the past 5 years has shot up in price because we're learning that's a limited resource. Where do we use copper? No. The penny is mostly zinc and it's coated with copper. No. We know where we use copper? All right, right here. Right here's some. In here, all the wiring for electricity. How many people live in a house that have about 1 billion outlets that you can plug something in anywhere, right? So all that wiring is very expensive, and people are changing back their PVC or CPVC pipes. You have plastic pipes in your basement. They're changing them back over to copper because the water is more pure and stays colder in copper. So there's a lot of reasons that we're using copper more and more and more. All right, we went away from it to use plastic, found out that plastic's not good, and now we're coming back to it. All right, solids. All right, solids includes rocks, shells, baseballs, tennis rackets, crystals. Books are solids. They have a definite shape and volume. Solids have a definite shape and volume. All right? I don't know what the shape could be. The shape could be anything, but it is definite, and it definitely has volume. How do we determine what volume is? There's 2 ways we can get volume. What are the 2 ways? Oh, man. Come on, math people. How can you figure out volume of something like this? I heard it. Length times width times height. If it looks like this, how the heck are you going to find the volume? Yes? When you're warm. Anybody? Bueller? Water displacement. Remember, we drop this thing in a certain amount of water. We'd see how much the water raises, and then we'd be able to tell what the volume of that thing was. Then if we had the mass, and we had the mass and the volume, we could figure out the density. Once we knew the density, then we can identify what the thing is. Because the density is a physical property. Okay? Pretty easy, right? Water displacement. Remember it. Get it in your brain. It's a good thing to know. Especially you're out naked and unafraid and you come across something, or you're in the middle of something and whatever. Okay, liquids. Include water, lakes, rain, and melted gold. Melted gold is a liquid, have definite volumes, but takes the shape of their container. See? What's the shape of this? The shape of that. That's a liquid. It's in the shape of that. Here's a liquid in the shape of this container. All right. All right, so it takes the shape of this container. Isn't that wonderful? What happens when it bust through its container. It's going to change shape, it's going to wreak some havoc, right? Wreak some havoc. All right, next, gases. Includes air, helium in a balloon, neon in a neon tube, fart. A fart is gas. They do not have definite shape or volume. All right? They do not have definite shape or volume. Unless you're in a car and somebody lights it up like my cousin Greg. My cousin Greg lights up my car every time I'm at home. The first thing I do, I get in my car at Christmas. We call him Schmeg because he smells like an egg, but his name's Greg. So we get in the car and it's always like, 39 years. He's been lighting up the car every time I'm in it. I'll walk in, it's like he's been saving up for like 4 years. It's terrible. So that actually takes the shape of the car. And I'm stuck in that. And I have to open the window. It's terrible. Okay. Anyways, I would definitely study this chart like it was my job. All right, so this is my second memorization chart. I would take both of these and I would put on Quizlet, make a Quizlet, make Quizlet. If it was me, I don't know. I don't really carry an iPad, but I do have a great idea. Tell me if this is an awesome idea. See this nice desk that you're sitting at? I want to make that whole thing a computer. So like you'd have your side and you'd have your side. And you could write on it, then I could be like, your picture would be right here, and I'd click your name, and your screen would pop right up there, and you'd have everything on one platform and everything. I think I could be rich. I think I can make this happen. I'm going to get rid of my spray-on waterproofer and go with this desk creation thing. You just write right on it, just like a notebook. It'll all go into the cloud and evaporate.
Did you ever get your waterproof thing to work?
Well, I mean, it's really hot. Okay. Identify the following state of matter for each of the following. This is so challenging. I don't know if you do it. A vitamin tablet is it a solid, liquid, or a gas? Oh, eye drops. No. Vegetable oil. No. Candle? A candle is solid, folks. A candle is solid. Air in a tire. Gas. And what's the shape of that gas? Okay, look at that. I don't even know. I don't even know. This is like 4th grade stuff. All right. Physical change occurs if there is a change in state, a change in the physical shape, no change in the identity of the composition. All right, let's do that. Let's check it out. All right, here. I'll make a physical change. You ready? Did you see that? That's freaking chemistry! Did you see that? All right, I'll do it one more time, Haley. You missed it. Physical change! Okay. I do try. A change in the state, a change in the physical shape, no change in the identity or composition of the substance. Okay. Let's see. How else could you do a physical change? Oh, I think I can do that. Here we go. Ready? I'll make a physical change. Here we go. Check it out. Yes. Woo! Crap. Where's my lighter? Must be in my car with my cancer stick. I would never smoke. It's a cancer stick. Where's my lighter? I used to have a lighter in here. All right, here, I'll do another physical change. You ready? Ready? I'm erasing it. Physical change. There you go. Okay. I'm done. Okay. Next. Examples of changes of state. Solid water melts to form liquid water. Liquid water boils and forms gaseous steam. All right. If you don't know these terms, please Get to know those terms: melting, freezing, boiling, and condensing. Ever hear those terms before? Okay. Okay, see, this is not hard. It's not hard. I'll have your test for you next class. They're going well. I'm still comparing you to fourth period, second gold 2. All right, so whoever comes out on top becomes my favorite honors chem class. So you are the dark horse. You two haven't taken the test yet. What if it goes down to you two for the class average? You better bring it. You better bring it. No pressure. No pressure. All right? All right. Examples of physical changes. Paper torn into little pieces. Let's see. Oh, nicely. All right, try it. Check. Go ahead, write that down. Let's see. I'm going to try another physical change. You ready? Here we go. Okay, sorry, I tried. Water poured into a glass, it changes its shape. All right, changes its shape. All right. Classify each of the following as a change of state or a change of shape. Chopping a wood into kindling wood. Shape. Water boiling in a pot. State. Ice cream melting. That's why you got to put it on the cold stone. Ice forming in a freezer. State. Cutting dough into strips. Yes, you guys. You guys. You got them all right. All right, chemical properties. Describe the ability of a substance to interact with other substances. This is perfect. What time is it? Because I'm going to do some cool chemical changes at the beginning of next class. All right? And then you're going to do some separation. All right? To interact with other substances, to change into a new substance. Iron has the ability to rust when exposed to oxygen. That's rust. See the rust? That's rust. This is iron. See the rust? Was it exposed to oxygen? What do you think rust is? Yes, iron 3 oxide. Or iron 2, it could be either one. But most likely iron 3. All right? Next, classify each of the following as chemical or physical property. Ice melts in the sun. Chemical or physical? Physical. Melting is physical. Copper is a shiny metal. Paper can burn. Chemical. A silver knife can tarnish. Chemical. A magnet removes iron particles. Physical. All right, from a mixture. Here are the answers. We've got them all right. I'm